Okay, welcome to FOSDEM. Welcome to my talk. Hello.
Microphone is just the screen. You have to talk louder.
Okay, thank you. Yeah. Today I'm going to tell you how we're using Wayland in IVI systems. I would like to give you a short overview what I'm doing in my daily life or in my work. I would give a really high-level overview of the Linux graphics stack, so you know which component I'm talking about and where we are placed in the stack. Then I would like you to explain why IVI system needs something different as a usual desktop system. And the main part should cover then the usage of FOSDEM as a Wayland compositor in IVI. And then I would also like to talk about what's coming next, what we're planning to do and what we already have done and are planning to upstream. So my name is Eugen Friedrich. I'm working from ADIT, for ADIT since 2010. I started handling graphics stacks in the company, and till today I'm doing the same job actually. I'm responsible for the complete graphics stack. It's a video in, display, pipeline, GPU, and all surrounding and related components. I would like also give you an overview what we are doing in ADIT, so you know why actually we need, why we choose the FOSDEM and Wayland as a graphics system. ADIT was grounded 2003 from Bosch and Denso. From those big two companies we are getting a lot of requirements. We need to harmonize them and create one single platform which will cover all the requirements. The biggest part of the software we are getting delivered, but still to implement the use cases we need to implement some additional components or enable features and modify the stacks a bit. Once we are done, actually it's never really done, so it's a continuous integration running and change requests and so on. We're delivering the platform to other companies and they're building projects on top of it. So for us it's very important to have something really generic here, which will cover both requirements and also practically there are like up to 10 projects using this at the same time. So this is the overview of the graphics stack, very simplified. You can see on the upper level the applications. They can use some frameworks. They will, in this diagram, they are all using Wayland. They have to talk with Wayland compositor, which is FOSDEM in this case. There is OpenGL driver. You can see here that the compositor and the applications are able to use the same driver thanks to the Wayland EGL implementation. And the compositor is actually then responsible to give the final content, final results of all applications to the kernel Mozilla driver and then to display. So I think that is. And now I would like to talk a bit more of FOSDEM itself. The FOSDEM has a really good defined plugin infrastructure. You can have, you have to have 3 plugins at least. One plugin is a renderer, which will use the OpenGL driver to make a composition, actually render the stuff in the compositor. There is a backend. Most of the time we are using the DRM backend, but you could also use, for example, Wayland backend, which will output the final result to a different Wayland compositor. So creating nested compositing is quite easy. And there is a shell. The shell is actually, or the implementation of the shell defines the window management. It will provide some Wayland protocols to the applications, and they have to use it and talk with this protocol to compositor to then request how they want to be presented. There is no different process or component which will decide how to behave. So this is all implemented in the shell. And this is exactly the main difference what we don't like in IVI, or what we cannot directly use in IVI, because our customers has very different requirements, very different ideas how the application would look like and the complete setup of the system. They could have screens with one application or 5 or 3. They want to have them slide away and flying in from different directions, and they also asking for us, for example, to implement something which will ensure that the arrangement of application and the application content change will happen in the same vision. It's quite hard to achieve because the APIs are asynchronously implemented. There are some events, and it's hard really to synchronize different protocols and APIs. Looking closer to our idea, so how to tackle this problem, we decided to implement a special shell which will provide the interface to outside, so you could implement your window management outside of Western. It should be really only this. It should be really a slim interface, or it is a slim interface, which will allow you to control the composition, but it will not take care of the actual rendering this stuff, and it will also not take care of how to output this to the final display. At the end, it actually could be not really a display, it could be some virtualized output or even a different compositor. And to implement this, we have now the IVI shell, which is living in Western itself. IVI shell can load additional plugins. Those plugins will implement Wayland protocol, and this protocol can be used to control the applications. On the application side, we also need to add something. Maybe it's not really the best idea if you are coming from desktop, but this is what IVI was using for a very long time. They always had some identifier for their applications. And this IVI application protocol is really slim, so it's small. It has, I think, one request and 2 events. We need this to assign unique ID to our Wayland surfaces. And of course, the drawback that application needs to be modified, or some framework needs to be modified to implement this and to assign ID, or to map the ID to the Wayland surface, which in Wayland represents the application or the content of the application. Looking closer to the implementation as such, how we realize this, the Western is its own open source project. The IVI shell is living inside Western, so it is in the Western repository, and the bluish plugins, they are in a different open source project. It's a Geneva project, and ADIT is maintainer of this. Here we are developing the controller plugins and maintaining this IVI VM protocol to control the application, IVI input protocol to control the input routing. There are also some minimalist examples and wrapper of the layer manager protocol, which will ensure compatibility to some defined API in Geneva for window management. Yes, what did you could also see that here inside of IVI shell, you could also have some HMI controller built in. This is a different plugin which can also implement the window management if you don't want to use this, and you know how your window management should look like. There is only one use case, or simple use case which can be implemented and which is really good defined. Then you can also do this with a HMI controller, which will then implement your window management. So, what we can do with the IVI protocol? It's quite simple. We have three types of object. We have a screen. This screen is actually mapped to the output struct of Western, which at the end represents a physical display most of the time. On the screen we can put some layers. Layers are just a logical object to group the surfaces. You can scale layers, you can make it invisible, you can define transparency and also change set order on the layers. And we have the IVI surfaces, which actually represent the application content. And there are some few events to get notification about new object in the system, about new surfaces, new IDs, if they're created and deleted, so that the HMI controller, which is sitting outside of Western, can react on this and make it visible. It is actually also not possible for application to be visible, so application cannot request make me visible. This logic has to be implemented in the HMI controller, which will get to know application is available. Then I would like to talk about this tiny thing, the application, the IVI application protocol. This was from, I think from this slide. Oh no, sorry, I'm spoiling my slides. This one. They had to modify the application of framework. Actually, we would like to get rid of this long term and convince also our customers to follow this. And the idea is to use a different protocol, because some protocol needs to be used from application side. We decided to focus on the XDG protocol, which is also defined by the Western community and actually used also already in some distributions and even different Wayland compositors. There is also a stable version of it, and we think this is a good protocol to be used in the future, also for IVI. But still we need to identify our applications, and we need to define the ID to be able to use the same IVI protocol. And we defined now additional plugin for Western, which is called ID agent. This is work is going to be upstreamed in the, I don't know, next week maybe. Patches are already provided. We are planning, so the generic idea is just to define how to assign the ID to the application. On the HTTP protocol, you have already a lot of stuff which you can use for identify, like a window name or application ID. And in the ID agent, you need to implement some logic which will take some of those attributes and will say, okay, if this application appears, then this is ID 5. You could also have this more complex, and your ID agent could also communicate with some database and ask someone to get the ID from this. But this is then up to implementer of this ID agent. We think that at the end, each project could have its own. We could provide some basic implementation which will look up some configuration XML or something like this. Yeah, this is how it will look like then if this will be implemented and available. we will still use the IVI shell, we will still use the HMI controller. The major change is actually only for application, and the biggest benefit we will get because of the application frameworks. Something like Qt or OpenSceneGraph already have support for XDG, but they also have support for IVI protocol, IVI application protocol, but it is not really good implemented and not really widely used. It's definitely better to focus on XDG protocol in the application frameworks. And with this IDEA agent implementation, we are able to make applications visible without any modifications in framework or application side. And of course, we cannot force the customers to use the XDG shell protocol. They can still use IVI application protocol. It's still available, it's supported. But I think long term, this will be a good idea also because of the compatibility. You can easily port, exchange, and also reuse applications, or just try some application to run a new IVI system which are already running somewhere else. Okay, the next use case we want to be able to manage with FOSDEM is a distributed HMI. This we're getting more and more requested to implement something which will realize the use case where you have a different hardware, different displays, the content is generated on one place and is presented on another. And there are also very different systems, and all this stuff is quite complex, and also the communications is very complex between those components and HMIs, and there is actually no real standard way to implement this. There are some components and some implementations available which will be able to help a lot. For example, Ramses, which was also open source recently from BMW, but we would also to be able to support this use case a bit better. And the idea is to implement another plugin for FOSDEM, which should use FOSDEM. FOSDEM is actually very similar to Wayland as such, but there is one major change or difference. It cannot carry file descriptors, but it can cross binary, so it can device. It can really communicate to outside. It can use TCP/IP sockets and get connected to a different system with Wayland. FOSDEM. The complete picture will look like this. We will get additional FOSDEM transmitter. This transmitter will actually implement one additional output object in FOSDEM. And if you will be outside of compositor, if you will be on application side or in framework, you will just see additional output. You should know this output is virtualized, and if you will put some content to it, then the FOSDEM transmitter will be notified and will start perform some action. So it will stream this to a different device. If you have virtualized system, it could use some graphic sharing mechanism to share the content and notify different operating system. The HMI controller is actually also a client of FOSDEM. It will also get this virtual output in the same way, so it can then use the IVI VM to assign application to this new created output. And yeah, this is the idea. But it is quite hard to implement something really generic which can be reused between Linux and Android or Android to Android, and some proprietary operating systems which are not widely used in desktop but in automotive. Also to implement the compatibility mode with hypervisors, it's quite challenging. But this is what we are planning to do next years. And those are just a list of questions what are like not solved now and where we are getting a request again and again. But for now there are no real solution, let me say, in the lower platform level. And we are still thinking how to solve this, how to implement this, or maybe the final result will be it's not meaningful to be implemented in Western, it should be done on the upper layers. Yeah, I think that's all for my talk. Do we have some questions? Oh, good. But not so good. Yeah.
Do you have a feeling of the latency now between what and remote displays and, for example, forwarded info?
Depending on what you will do, the Linux kernel is very fast. If you will use a very simple system without load, in real test we could not recognize. So you should be very careful looking to a display to see where is the original content and where is the fake output content. But it's again like it's idle system without any load. The real use case will be maybe a little bit hard, but I cannot tell you the number in milliseconds. But it's usable, definitely. Yeah.
IVI Shell was originally designed with the idea of a single full screen only and one screen per device. In modern cars, that's quite out of fashion, I would say. Do you still believe that IVI Shell, as a key design, make a sense, or could we use an XBG concept and just have a controller to stop the application to do whatever they want? Because it creates a lot of side effects without specific.
Actually, I don't think that IVI Shell somehow limits you to the number of displays output. So it's not related. If you have 5 outputs, you can use them all.
It's difficult to manage them. You have different size of screens and different color depths. It doesn't manage that at all.
I know, but
so we know it's difficult.
IVI Shell is will not limit you to do this. What will happen if you use IVI Shell? Then you will have differently arranged displays. So in default behavior of FOSDEM, that it will extend the display. You will have all the display in one big coordinate space. If you will use IVI Shell, you will get this completely distinct. So it will be different displays with different resolutions. So you cannot have a one common virtual space, but you could arrange your layer and surface setup that it will look like one common space. So it's, but I think especially for the IVI, you don't want to have extended displays. You have to have separate.
A very typical use case is to move, for example, the map.
Yeah.
From the big screen to the small screen under when you have another application starting out. That's difficult. You probably have to design the application in line with the hardware, which is really very old-fashioned and extremely limited. Because it means the application has to get the knowledge of the real implementation of the graphics side.
So maybe we can talk later. There is a way to realize this use case with the IVI-VM protocol. Where you can move your application to a different screen with the same application content, same surface. Because I didn't show this here. What you can do, you can assign the same surface to different layers at the same time. But you cannot assign the same layer to different screens. This we didn't implement because of complexity. But if you will assign your surface to different layers, you can use the layer capabilities to scale this differently and assign this to different display with different resolution. This would be...
Okay, so we're out of time for more questions, so thank you.
Okay. Yeah.